Good morning, everybody. This is Mr. Sam, and hope everyone had a great first week of non-traditional instruction, remote learning. We're going to start this week off talking about another type of covalent compound that has a slightly different rules for naming, and that notably are the acids. Acids are something we encounter a lot in the chemistry laboratory and chemistry in general, so it's nice to know how they're named. So there's two simple ideas here, and then we'll have some practice today. So let's start out with that there are two kinds of acids, and the major types of acids are pretty simple. There's the non-oxyacids. Non-oxyacids, as their name entails, have no oxygen in their formula. They're usually binary, which means there's two elements connected together. And these two elements are usually hydrogen and another element. So they're binary meaning two. So there's no oxygen involved. So just a hydrogen and another element stuck together, no oxygen. Those are going to be your non-oxyacids. The oxyacids are the ones with oxygen in them. And along with the oxygen, usually the oxygen is part of a polyatomic ion, the things that we learned about last chapter, like nitrate, nitrite, sulfate, sulfite, phosphate, all those things that have oxygen in them. They're polyatomic ions. And if those are connected together with a hydrogen, you're going to get an oxyacid. So an oxyacid has oxygen in it and it's part of a polyatomic ion normally. And we'll see examples of that pretty soon. Let's start with the non-oxyacids because non-oxyacids, I think, are the simpler rules. These are usually only acids when they are dissolved in water. So they're not acids if they're gases. So they're only going to be classified as an acid if they're dissolved in water or if they're part of a solution. So that's sort of how it works with the non-oxyacids. To know that, so you are aware of that, in a chemical equation, they're going to have the abbreviation AQ behind the chemical. AQ means aqueous. It means it's in a water solution. And we're going to see that a lot in the next chapter when we start talking about chemical reactions. So if you want to kind of know that they're dissolved in water, they would put AQ for aqueous, aqua, that word water. The first part of the name of every single non-oxyacid is the word hydro. And this is kind of different than what we've ever seen before. Hydro begins the name. Luckily, they all begin with the letter H, so it's kind of easy to remember. But so if you see a non-oxyacid begin with hydro, it has basically then three parts, these non-oxyacids. Hydro, always. And then the root of the anion name. So whatever the second element is, remember the first element's H, second element is a non-oxygen, but it's something else. It's going to be an anion, a negatively charged non-metal. But we don't use the IDE ending anymore. We don't say bromide or we don't say chloride. We change it a little bit. We actually put an ic at the end, IC, to the root, and then you write acid at the end. That's going to be very common. Acids always have the word acid at the end. So we have hydro, the root, and ic. Hydro, root, and ic. So, for example, H2S, AQ means it's dissolved in water, that's sulfide, S. Numbers don't matter here. There's no prefixes for numbers of the subscript. That would be hydrosulfuric acid, hydrosulfuric acid. Sulfur is the only exception that you actually use the full name before you put the ic, because it just sounds better that way. Chemists are very practical that way. So hydrosulfuric acid, one word, hydrosulfuric. And always put the word acid at the end. So that's how you do that one. HCl, very commonly used in labs. AQ's there, it means it's dissolved in water. Obviously a non-oxyacid because there's an H and a Cl, it's binary, only two elements. So that would be hydrochloric acid, not hydrochloride acid. Hydrochloric, the ic has to be at the end. Hydrochloric acid. And finally, that's cyanide. That is a polyatomic ion, CN. It's on that list we had last chapter. But in this case, it would be follow the non-oxyacid rules because there's no oxygen in it. It's an acid. It's dissolved in water. It begins with H. So we would call that hydrocyanic acid. cyanide, cyanic acid, hydrocyanic acid. Let me move that out of the way there. We lost it. We're back. Hydrocyanic acid. So those are three great examples. The middle one there being a very common one, hydrochloric acid. So that's how you do non-oxyacids. Now the oxyacids, the final one today. The oxyacids, they are named slightly differently with a couple additional rules. They have names that start with the root name of the anion. So they actually start with, they don't put hydro in the front. So they start with the root name of that second part, the anion, the negatively charged thing. The root of the anion name you start with first. And then here's the thing. Remember how we said these are like nitrate, nitrite, phosphate, phosphite. They're always going to be those polyatomic ions that had O in them. Well, if it was an 8 ending, if it had like an 8, ATE at the end, like this, you put ic at the end of your anion name. If it was ite, like nitrite, phosphite, sulfite, you put OUS, us. And this is historically going to confuse students, so you just kind of pay attention to it. And then the word acid at the end. Notice you don't put hydro at the beginning. You go right into it. You go root name of the anion, put your ending, ic or us, and acid. And the ic or us all depends on if it's an 8 or an ite. That's how you tell your reader or your colleagues in the lab which one you're using. Never use hydro with oxyacids. So you know it's an oxyacid immediately if there's no hydro in the front of it. Some examples are going to help, and then we'll be pretty much done for the day's lecture. HNO3. HNO3, there's an H in the beginning, and that's a polyatomic ion called nitrate. Obviously, pull back that list if you pull up that list if you want to see it. But NO3 is nitrate. The ion list will help you a lot here. HNO3, you would say nitric acid. Why ic? Because it's an 8. 8s are the ics. Nitric acid. No hydro, just nitric acid. HClO3, if you look that one up, ClO3 has an O in it, so it's an oxyacid. HCl3, it's an H, so it's an acid. That's a chlorate ion. ClO3 is called chlorate. It's an 8, so you have to put ic, just like nitric acid. So it's chloric acid. This is called chlorate. You put chloric acid. So that would be called chloric acid. H2SO3. Well, SO3 is called sulfite. SO4 is sulfate. SO3 is sulfite. So SO3, since it's sulfite, you had to put the OUS ending. So that'd be sulfurous acid. Remember, sulfur, you actually use the whole word. You don't use a root like with nitrogen and chlorine. Sulfurous acid, because it's an ite. Okay, I think you got it all. At least I hope you do. If you don't, I would always ask questions. This is not a huge part of our naming, but it is something I want you to be aware of. There are asks out there. I will give you a small assignment today just to practice a couple other ones. But we'll end this with a riddle because you're missing my really bad jokes, I'm sure. If H2O is water, what is H2O for? Some of you guys are saying what? Dihydrogen tetraoxide? No. It's for drinking and bathing and washing and swimming. You get the point. You guys have a great day. I'll see you again real soon. Thanks.